morning, good afternoon, good evening to wherever you are. I'm Samir. I'm an enterprise architect, part of the digital group within Atos. I'm based out of Mumbai. I've been in Atos for almost 7 years now. I primarily lead and drive the pre-sales for large deals for the Northern Europe geo. Uh, I'm a distinguished expert in modernization domain and drive the architecting and building of innovative cloud solutions and applications and computing systems. I also provide architecture and technology leadership and expertise to large transformation and modernization programs and complex large deals for Fortune 100 customers. All right. All right. So here's the agenda for the presentation today. We basically start with the integration platform journey in terms of how it started with point-to-point integrations and platforms such as Korba and DICOM. Then we touch upon the legacy middleware challenges that we have today in the platform in terms of the business and the technology challenges. We'll touch upon some of the key ones. Then comes the dimensions of the integration platforms and the integration framework, which typically is one of the reference architectures which will be which is typically leveraged when you're actually building a target state or a future state for your integration platform. Then actually the presentation covers the integration approach, which basically provides a view on how you evangelize the digital integration platforms that we build today for large enterprises, large complex systems. And then basically the key platforms that I want to touch upon will include the integration platform as a service, which is one of the key solutions today, a cloud native solution today that we have as part of the various cloud platforms that we have and vendor products. These integration platforms or iPaaS platforms are actually typically bundled with monitoring and DevOps platform as well. So I think that's something that I'll also touch upon. Then comes the event-driven architectures, which are the eventing backbones that are required to build real-time systems that we have today. So that's something that we'll cover as part of the presentation. And the hybrid integration platform as well, which is basically a mix of a combination of various sort of tools and solutions in the integration space to build a solution that can basically cater to a specific needs for an enterprise. So this is basically what we'll cover as part of the presentation. So I'll sort of move to the next slide now. So this is basically the integration tooling journey that is depicted here. It started with the early 90s when we had point-to-point integrations built as part of the landscape, leveraging tools and solutions like Korba and DICOM. I think this is basically something that created a spaghetti-like solutions that were too complex and to handle and manage. So this basically was then replaced with second generation integration platform, which had message brokers, hub and which provided hub and spoke architectures and business to business integration. So this basically had elements of the solutions that we still have today in the form of message brokers and B2B integrations. The third generation of integration platforms actually covered elements of web services and service-oriented architecture. So these were actually suite of products which had various things in terms of the integration service bus, the message brokers, your point-to-point communication using message queues, etc. as well. And then this is a generation next technologies that we have today in current era, where we have microservices and cloud native iPaaS applications. These are also called as a hybrid platforms. These are provided by various vendors like Azure. We have things like Dell Boomi. We have IBM. So I think there are various vendor products that are available as well. So this basically something that is a depiction. So I think from this legacy standpoint, enterprises update and modernize their IT infrastructure as they move to the cloud and implement IT strategies. However, one essential component is often falls behind is the middleware. So yesterday's middleware was strictly on-premise and didn't support the real-time interactions that modern businesses required. right? So failing to address middleware modernization while addressing the modernization of other parts of the legacy environments risks deepening technical debts, thus undermining your ability to execute on the initiatives that drive innovation and agility. Uh, which would put the enterprises at a competitive disadvantage. Complicating the legacy middleware challenges is the rise of cloud computing and cloud native architectures and solutions like Kubernetes and containers and microservices. So this is basically something that is typically the journey of the integration tooling platforms. I'll move on to the next slide now. So I think from a legacy standpoint, from a limitations of legacy standpoint, as middle ages, it can place undue as middleware ages, it can place undue limitations on anything it touches, including application services. Uh, oh God, it's sorry, Daryl. I think it's basically automatically advancing the slide. I'm not too sure what is the reason behind it, but I think we'll have to do something about it. Uh, I think. I'll just progress it to the earlier slide and continue. Uh, as middleware ages, it can place undue limitations on anything it touches, including application services and systems. Furthermore, by its very nature, it is difficult to replace as it connects to many different parts of IT landscape. The rise of cloud computing, more than any other innovation, has been driving the obsolescence of legacy middleware. The reason simply connecting on-premise endpoints to cloud endpoints doesn't address the limitations of older middleware products. Connectivity is but one of the number one considerations. Organizations are also increasingly moving to real-time business models that are older middlewares can't keep up with. Security and compliance, especially in cloud, are providing novel challenges alien to on-premise technologies. And perhaps most importantly, the nature of endpoints themselves are changing. Gone are the stable applications with fixed APIs. Today's middleware is likely to have to connect to dynamic microservices, an entirely new challenge that legacy middleware simply isn't up to. So in terms of the limitation, uh, in the past, companies have integrated their business processes through custom programming, enterprise middleware, or enterprise application integration, implementing such as service-oriented architecture. These solutions work, but were expensive and time-consuming to create. They also left companies susceptible to data silos. So one part of the organization did not have visibility into another, creating inefficiencies while data needed to be shared. Over the past decade, companies have rapidly transitioned to cloud services and convenience of SaaS platforms. With a vast number of SaaS applications being integrated within a single organization today, it has become unwieldy of IT departments to build customer programming, middleware, or other implementations for each of these offerings. In addition, the expansion of network services, edge computing, and Internet of Things has created further demand for rapid integrations with a wide range of products and solutions. Companies today must be able to rapidly integrate data services that live on premises, in private cloud, and at edge, and multiple vendors in public cloud. So I think from a limitation standpoint, the business specific limitations include uh, the limited the promise, flexibility, benefits, and reuse are not realized by the middleware platform. That's one of the key ones. Integration and maintenance costs spiral out of control is something that is a very common sort of challenge when it comes to legacy middleware. The business is dissatisfied with time to market on projects and implementation roadmap. Applications are sprawling. The business is asking for even greater application diversity and flexibility. Tool focus resulting in very chaotic implementations that are inflexible and provide spaghetti like architectures. In some cases, the limitations of synchronous or asynchronous disaster recovery, depending on form factor, lack of visibility into what existing integrations and how they are leveraged. So I think it typically lack various elements of visibility around what integration platforms are, what are the different tools that are leveraged, and exactly how they are integrated into the landscape. Complexity of managing multiple tools. This is one common problem where we have multiple tools and solutions to basically deliver a middleware platform. And outdated and inflexible systems that are not well positioned to integrate with other platforms. So that's a common challenge. And also it gets outdated with new technologies and solutions coming in. Cloud strategies, mobile applications, and expanding information opportunities are adding further complexity to the integration space. So this basically covers the business side of things. We also have limitations of legacy integration systems, when it comes to the technology domain. So in terms of the technology domain, the legacy messaging systems long rely on long topic structures that create for heavy work for applications, which can cause issues with availability and responsiveness in a certain condition. Legacy messaging systems aren't easy to scale because horizontal scaling doesn't work due to feature disparity between platforms, and vertical scaling requires downtime. Legacy messaging systems doesn't let you add brokers to a running system. Legacy messaging systems were designed for point-to-point or request response patterns, and their support for pub sub and eventing is limited since they are based on queues. Messaging vendors are infamous for tying in other components of your IT estate and create vendor lock-in that hampers your ability to innovate. Most messaging systems require you to deploy several components that don't provide backward compatibility. Most messaging systems don't replicate and maintain states in backup brokers, so recovery attempts can take minutes to get underway and not resolve for hours if you have large queues. Most legacy messaging systems are unable to deliver messages to slow or disconnected consumers, which can disrupt business processes and put back pressures on publishers, preventing them from sending messages. Worst of all, this usually occurs during periods of peak activity like big product launches or seasonal sales. Most legacy systems don't make it easy to deploy systems that span on cloud and on-premise environments. If they do, they provide different functionality or are managed with different set of tools and solutions. Most legacy platforms aren't natively sensitive to events and can identify or catalog events even within their platform. So these basically are the sort of key challenges that you find as part of the legacy platforms. I'll move on to the next slide. But before that, I just want to touch on the key considerations to modernizing middleware. Understanding the real-time imperative, one of the most important yet subtle business requirements for IT infrastructure is a real-time behavior. Whether it is meeting customer needs or on mobile app or website, or supporting core business processes of an enterprise, the business typically wants everything right now. Real time, however, doesn't actually mean simultaneous. So just how fast real time behavior really depends on the context of interaction. Real time responses on the web page might be less than 2 seconds, while real time stock trading might happen on the order of milliseconds. In other words, real time fundamentally means as fast as the business wants. Legacy middleware technology supports a range of different integration patterns, some of which would qualify as real time, but may would not. The most common of these patterns, queuing, is able to guarantee delivery of messages but allows them to connect in a queue, thus introducing delays. The behavior would be adequate for committing the financial transactions in a database. Other situations like real-time market data, credit card transactions, or monitoring mission critical systems may not fare so well. Sometimes the business challenge centers on movement of large or frequent data sets. Problems we now lump into categories of big data. Legacy middleware places limits on big data, as these older technologies date from a time where data sets were much smaller. The broader real-time challenge, however, centers on business events. As events in a message that corresponds to particular time and place. Business events are events which are relevant to businesses. So this basically is one of the key asks that is basically required to be delivered by the integration platforms. When it comes to actually the dimension of the integration platform, we have around 4 personas, right? Uh, this actually includes the integration persona, the integration domains, the endpoints, or the integration touch points, and the standards and the protocols. So when we are actually building an integration solution, I think this is what we need to consider when we are actually evangelizing the target state. So integration persona is basically something where understanding who will deliver the integration outcome and will significantly narrow the field in some case in terms of approaches available. This may well be driven by the context. The outcome is to be produced within the integration domains. With no existing integration tool portfolio and no integration specialist, a business approaching a need to connect a few SaaS systems may well decide on an approach of an iPaaS or a pure citizen integrator. So I think as it actually depends on what kind of integration sort of platform you want to evangelize. So I think if it's not complex enough, I think you can as well go with citizen integration integrators where you'll actually build using, let's say, a typical low-code platform. But if the complexity is high, you definitely need integration specialist and data specialist for that. You can also potentially leverage an iPaaS approach for publishing consuming events, but not in the absence of eventing backbone. So I think as the complexity gets higher, you'll need more and more solutions and services to basically build the platform for you. With less specific integration needs, broader choices in the approach presence, the key takeaway from this is to recognize integration approach is heavily influenced by technologies being integrated, which is going on around what is going on around those technology tends to drive the choice we make at the very least is to exclude the certain approaches, right? So I think one of the key things is to also sort of, for most organizations, some of the forms of integration choices that is dictating an approach has already been made, and often architects will refer to that as a strategic choice. So I think that the choice or the strategic platform has already been made, and I think that basically drives the implementation and deployment of a platform. There's normally a hint of legacy that the choice in the choice as well. That's not to say there is anything wrong with the technology or the solution, though strategic generally means it is solving a lot of problems for an organization. So I think that's also one of the things that there's no reason to replace it, or nobody has the appetite to replace it. So I think if you have strategic choices, I think that's basically a platform that we have developed, which is basically with a vision, with a long-term vision in mind. So I think when it comes to integration endpoints, I think we'll have various endpoints to cater to. All the systems installed on premise are, and there will be systems that will be deployed on cloud as well. Organizations connecting to these various examples often arrive at a subset of choices in terms of integration approaches. So I think you typically have either all the things or some of these things based on what requirements you have. So we'll basically have a platform where you need to do application-based integration, data integration, process integration, or event integration, and basically may leave out the B2B integration altogether. So this is basically how you typically evangelize. When it comes to endpoint, definitely we have on-premise, on-cloud, mobile, and IoT endpoints. So this is basically how you typically sort of build the platforms, which basically also includes these four key elements. And then it comes to standards and protocols. I think we'll have the integration technology standards and protocols can be driven by what a vendor supports as much as what an organization strategically does. Where an organization already has significant investment in the cloud platform like AWS, Azure, this may lead to obvious choice in the approach. So I think the choice of platform will basically drive what approach you take for the various standards and protocols. Regulatory requirements regarding types of data can also influence those decisions and affect the overall approach. The same is true where a technology is being integrated, as this often requires an embedded solution. So I think some of the core things that I would like to also touch upon is when it comes to communication protocols, these platforms typically provide support for FTP, HTTP, AMQP, MQTT, etc. They also have various connectors or adapters in place for SaaS platforms, the enterprise solutions, the various vendor solutions as well. It can actually have various data formats like XML, JSON, ASN, etc. And also the data standard support, which will have HL7, Swift, EDFACT, etc. So these are basically what we should consider when we basically are evangelizing your integration platform. So I'll move on to the next slide, which actually talks about the reference architecture. So this is a view on exactly how you will basically build your target state. So it basically provides role-based users interface, which is basically the integration sort of persona that we touched upon earlier. Then you have various approaches in terms of what you want to build be it the microservices-based approach or request response approach, an event-driven approach, a file-based approach, etc. This basically in terms of what will be required to be actually sort of provided. Then there are various scenarios around it. So it's whether you have an application based integration scenario or a process-based integration scenario or a robotic process automation-based scenario. So this is basically the overall view on that. Then the integration sort of solutions around it. What are the solutions that actually provide these scenarios and build these approaches? So we have API management, the enterprise service bus, the message queues, event brokers, etc. And then there are these horizontal offerings that we have, right? So DevOps, observability, security, Active Directory as well. And then it comes to governance, so lifecycle management, metadata management, API policy management around it. So then these are the basically elements that we would want to actually sort of consider when we are actually working on the digital integration platforms. And then it comes to the deployment models as well, where you have on-site and offshore and edge kind of deployment. So I think when it comes to the integration framework, which is a layered way of looking at roles, scenarios, building blocks, solutions, deployment models, and governance for the integration capability, we view it as an agnostic, as a technology agnostic a vendor product or technology agnostic solution, because organizations are not necessarily best served by integration platform offering from one solution from one particular vendor. One throat to choke may be a nice support term, but it can lead to people viewing the vendor stack on one level from an operational or governance perspective. We should be able to operate with different levels of governance around different technologies and achieve different levels of agility with them. When a vendor is able to offer an integration platform or hybrid integration platform, it is generally achieved through portfolio of products, some of which may be white label technologies from other vendors. Hybrid integration platform refers to a portfolio of technologies and approaches. So I think it's a mix and a combination of various technologies and approaches. So when it comes to, I think the another important thing that I also want to touch upon is basically the integration approach that we should take to deploy and build integration platforms. So integration has historically always been a pain area. So the business case for implementing it is generally based on the pain of doing nothing. Double keying data inconsistency or inaccuracy, missed orders or inability to invoice, and many more examples of cost or pain of organization endures without integration. Pain creates a tipping point that justifies the investment in technology. It's certainly a key driver for market. Digital transformation has shifted things somewhere in terms of viewing integration more as an enabler than a pain mitigator. The API economy has also made many organizations see integration as an opportunity. Regardless, the key thing to understand is that we should always consider value when we select an approach, whether you are a large organization with existing integration tooling or small businesses embarking on integration systems for the first time. You should always look for an approach that appropriately addresses the value of what you are doing. That you have existing tooling doesn't mean the approach that the tooling dictates is suitable to address the value of current desired outcome. A multi-million-dollar integrated outcome running through citizen integrated tooling may represent great value. It may represent a failure to value the integrated outcome right way. Having a strategy of microservices through your application development organization doesn't necessarily make it make the right approach for every integration scenario. It makes it a consideration or additional context for the decision. That doesn't mean you should invest in new technology each time a new integration challenge surfaces. It means value the approach you take and make sure it is appropriate. It's okay to have more than one tool in the toolbox if the value stacks up. All right, selecting the right approach and identifying the right technology are decisions we should take every time our IT landscape shifts. The business case for any given approach doesn't necessarily stack up for every scenario. This is where the integration framework becomes valuable to organizations. It allows organizations to select the right approach and technology mix for each scenario. For small organizations, thinking in integration framework terms allows organizations to recognize what when the hammer in the toolbox isn't the right approach for the integration problem that doesn't resemble a nail. So they will have basically this provides you a kind of a guideline to actually build your integration platform. So this covers the integration reference framework that we have. I'll move on to the business scenarios and the integration platform use cases that are very that would be critical while you are actually evangelizing the integration the digital integration platforms. I'll touch upon some of the key ones that are in the scope of the digital integration platform. So this is what we typically would ask while we are actually building the integration platform or basically working on gathering requirements for the integration platform. So this is basically are the key ones that come up. So does your solution make it easy to ingest, combine, and route data concurrently between systems? So this is a key one. So this basically matters because this platform should get data movement totally of the mind of your application. The producers and consumers of the data should be able to send data on any messaging pattern, be it publish, subscribe, streaming, or request response pattern, or be it message queues. The second one is, does your solution let publishers, subscribers interacting using multiple protocols and formats? So this matters because we'll have to basically see if we are able to receive messages over MQTT or AMQP, and then being able to publish it over JMS, which basically will be really a kind of a flexible solution that we have. That's why I look for patterns or look for platforms that transform data using popular open protocols like AMQP, MQTT, JMS, etc. Can the solution reply a sequence of messages or replay a sequence of messages while preserving the order in which they can send? So this can be a mission critical requirement since it relates to use cases like uh, data replication or basically your disaster recovery. Can your solution guarantee delivery of events with no data loss? Also, this matters because software brokers are known to show high performance numbers since they hold messages in the RAM and only batch them to disk. We don't have to tell you what happens if the power fail when the data is in the RAM. So this basically is a consideration to be given to the solution, whether what kind of sort of technology it uses to implement that kind of a sort of capability. Does your solution secure data at rest or in motion? So this basically boils down to the fact that whether you have the right set of security uh, in place to ensure that you have secured the data and encrypted the data or provided a TLS based authentication around your solution. The next one is, can the solution deliver infrastructure as a code using tools like Terraform or Jenkins? This is basically one of the asks that we have in not just your integration platform, but your overall solution or overall application landscape to basically have a CI/CD pipeline to build um, to build uh, your continuous integration, continuous development, your DevOps like a sort of platform for your entire landscape. The next one is, does your solution integrate with machine learnings and other services in the cloud? So this is something that is of tremendous sort of value to the uh, to the um, to the organizations, because I think these are the new sort of elements, new capabilities that are provided by cloud players like AWS, Azure, and GCP, and they offer tremendous powerful services to analyze your data and events to basically ensure that you have the right solution in place to analyze your anomalies and probably predict faults that are happening in your integration landscape. Does your solution prevent split brain scenarios? So this is something which basically is, having a standby broker is great, but you need to know how a streaming platform detects and prevents the primary and backup brokers from going active at the same time. So basically an intelligence that you need in the platform. Is your solution built with architecture that's good for streaming? So again, it's become a common to carry out an SQL by query both on data that is in transit and at rest. So I think this becomes even more uh, critical when you're actually sort of having the streaming requirement for your platform. How does your solution manage low or offline consumers? Some systems put pressure on publishers, which can take your applications and microservices behave erratically. Some might even need a robot reboot of the platform, of if the platform cannot efficiently absorb and control the flow of messages. So this is basically another key one. And most importantly is the throughput does the solution offer. It's important to compare message rates based on the type of application rewrites you need and support in order processing. So these are the key sort of business scenarios that needs to be considered. And actually this probably slide actually provides you with the solution themes as well. But I've just tried giving you a view on what are the key elements that would go on when you're actually sort of considering the platform, when you're actually evangelizing the platform, digital platform for an enterprise. The next one is, of course, the solution principle. So when you're actually sort of building the platform, these are the key solution principles that you'll actually consider. So one is being a cloud native, which provides benefits like automation, scaling, serverless operations, which are and highly customizable. Platforms are fully managed by vendor, which frees customers from worrying of building, hosting, scaling, managing, monitoring, and maintaining the solutions. So hybrid integration is the next one. In the integration processes need to run in multiple deployment scenarios, whether multi-cloud or on-premise. Deploying applications and not worrying about where they are is basically one of the key solution principles. Efficiency and control is the next one. The platform is highly configurable and provides a kind of a plug and play architecture, providing agility and faster time to market. In terms of the NFRs, the customer load increases, the platform allocates more resources automatically. This can speed up the development time and provides a competitive edge for the enterprise. Observability is one of the key elements again, which is integrated with the digital platform these days. This enables the monitoring, governance of application and integration in real time. This feature implies having reactive observation events that react to monitoring events, such as alerts when thresholds are breached. This also enables end-to-end detailed traceability from integration source to destination. Then comes the ease of maintainability. Platforms are fully managed by the vendor, which frees the enterprise from worrying of building, hosting, scaling, managing, monitoring, and maintaining the solution. So I think these are the key solution principles that we look for while building the digital platform, digital integration platform. So I'll move on to the next slide, which is basically a depiction of the digital integration platform, a cloud native solution, which is also one of the key solutions that we have today, which is also called as the integration platform as a service, IPaaS. So the IPaaS or integration platform as a service is a self-service cloud-based solution that standardizes how applications are integrated. Right, developers, consultant, and even non-technical users can use IPaaS out of the box to quickly build the integration flows for sharing data within an organizations or within multiple companies. With IPaaS, organizations can more easily connect different applications, data, business processes, and services, whether they are hosted on premise, in a private cloud, or a public cloud environment. IPaaS also gives DevOps and IT departments a way to build integrations quickly and enable real-time updates throughout the applications organization's application estate. Integration and platforms are also called as cloud integration or cloud-based integration. iPaaS provides a single toolset and a consistent process for integration between all the applications in the enterprise within whether they are on premise or in the cloud. The platform is hosted and managed by your cloud provider and offers as a service. You simply subscribe to the platform, choose the tools and services you need to configure, and automate integration between applications, and you get to work. The cloud provider handles the rest, including data governance, security, software patches, hardware management, new features updates, whenever they become available. Pricing the iPaaS is structured as a monthly subscription fee, so it's pay-as-you-go model. Once implemented, the iPaaS provider offers a wide range of enterprise integration scenarios, including those for highly regulated industries. iPaaS supports real-time exchange between SaaS application as well as between SaaS applications and other applications located in the cloud. SaaS, SaaS and on-premise applications, which are basically a kind of a complete ecosystem. So this basically is a view on the Azure as I said, Azure native solutions. It basically provides what all things are embedded or bundled as part of the platform. So we have API gateways, enterprise service bus, which basically is the publish subscribe model, all right, or the message broker model. We also have components or services which provides message queuing based interface where we can actually sort of build integrations using message queues. Then we have the workflow engine or the orchestration engine that is provided as part of the platform as well. Then we have the message or we have the eventing solution, which is basically provides the event streaming, event hubs, the real-time sort of the event that you need as part of your integration platform. Then is the Azure Data Factory, which basically is data ingestion, right, and data transformation as well. So this is basically typically considered as kind of a batch mode integration between various applications in your system. Then you have the file-based transfer as well. So this is basically another key component. As said, this basically also bundles various elements of things like Azure sort of gateway, basically for hybrid connectivity. You have extendability through, let's say, Azure functions, etc. And then you have the system integrator or the citizen integrator for that matter, where you have the low code ability to build integrations using a UI based or the complete integrated development editor to build your integration using a model based integration. And then you have the Azure monitoring or the monitoring kind of a capability as well. So this is basically the a key platform in that is basically leveraged by enterprises today. The benefits of this platform that I would like to touch upon is faster time to value. So obviously when it's on everything is bundled as services, your operations and development team can help themselves to iPaaS by simply subscribing and basically starting these services and integrating these services with your solution. It provides better integration results with less work and fewer specialized skills. So I think it's completely bundled as part of one sort of modeling environment, one integrated development environments. So basically, iPaaS typically offers integrated intelligent work saving tools and high productivity interface that can help users punch above their weight and achieve better, richer integrations in a short period of time and without having to build newer functionality each time, because I think it's bundled out of the box. Improve scalability as well. The self-service model of iPaaS scales easily as your integrations need to grow. So I think it definitely provides the horizontal and vertical scaling that you need as part of the platform. Reduce integration cost, because I think iPaaS solutions are typically much less expensive and time consuming than custom integration. Message-oriented middleware and enterprise integration products such as ESB, enterprise application integration. The reduced cost and faster implementation makes integration a possibility for more mid-size and smaller businesses as well. So it's not just a platform for enterprises, but even the small and mid-segment companies can leverage this, considering that you'll basically provide the return on investment. We have improved connectivity. When processes and data are updated across applications throughout the organization, anyone can get the data they need when they need it. So I think it basically provides with a lot of options for application data connectivity, etc. Built-in API management. So iPaaS eliminates the need to publish customer APIs or combine APIs from other services. It's all in iPaaS solution. So creating more scalable and secure solution for managing APIs. So API management is also part of the platform. Simplified and improved B2B integration. So every business has its own process of exchanging information with partners. Different applications used at different companies make it difficult to communicate. So businesses can use iPaaS to improve business-to-business integration and ultimately increase the revenues to improve the time to market. So I think, as you can see, this basically is a comprehensive platform providing various capabilities, which we just touched upon, and also touched upon the various benefits that we provide. So I think let's move on to and also these platforms are highly customizable. So these services can actually be deployed and quickly integrated with various solutions and systems that you have. So I think as this a diagram typically depicts on the right side, we can have the various business platforms, let's say the digital enable platform or the customer contact center or the customer banking platform or your legacy platform, and it still provides you with with the plug and play architecture, where you can actually leverage these solutions to build various integration scenarios. So the next key platform that we have is again bundled, typically bundled with the monitoring, typically bundled with the integration platform, which is basically the monitoring platform that we have. Again, this view provides with a kind of a Azure native platform that we have in the landscape. And it actually provides you with various elements or the building blocks that we have. So it will provide core capabilities which will facilitate application monitoring, infra monitoring. It will provide you with various analytics related capabilities, be it metrics, be it logs, right? So these are basically the analytics platform that you have on top of your application and infra monitoring. And then you have the visualize and response, where you have the dashboards and your business intelligence tools to basically provide you with the intelligence around your entire integration platform. And this cannot just be leveraged by your integration platform, but this actually cuts across your entire enterprise applications as well, SaaS applications as well, your on-premise applications as well. So I think this basically provides you a kind of a elaborate capability to basically monitor your entire application state. So I think from a monitoring standpoint perspective, I think this helps you maximize the availability and performance of your applications and services. It delivers a comprehensive solution for connecting, analyzing, and acting on telemetry for your cloud and on-premise environments. This information helps you understand how your applications are performing and proactively identify issues affecting them and resources they deploy. The monitoring provides the following capabilities, right? Detect and diagnose issues across application and dependencies with your application analytics and insights. Correlate the infrastructure issues and anomalies with your virtual machines and all your container and application insights that you have. Drill into your monitoring data with log insights for troubleshooting and deep diagnostics. So apart from just the dashboards and your alerts or reports that you have, you can actually sort of have an analytics capability run into or analyze your data to come up with what exactly is happening in your systems and analyze the root cause and anomalies in your platforms. Support operations at scale with smart alerts and automated actions. So this basically provides you with automated actions you can actually build. If in case there's an anomaly detected or in case there's an issue detected, you can have a kind of an automated process to detect it and do a kind of autocorrect, leveraging, deploying your various elements or solutions, leveraging this tool. And of course, the visualizations as I have mentioned. So this is basically the monitoring platform that typically is a bundle as part of your integration platform as well. Then comes the DevOps, which is again a kind of a key solution or a key platform that we have as part of your solution. I'm covering this as part of the integration platform because I think integration platform typically leverages this. At times it may not be bundled with the integration platform, but integration platform leverages this solution to provide the CI/CD automation or the dev automation pipeline, DevOps automation pipeline that is required. So DevOps, as we know, is a process framework that ensures collaboration between development and operations team to deploy code to production even faster in a repeatable and an automated way. The word DevOps is an amalgamation of two words, right? Development and operations. DevOps helps to increase. I think the key is to it helps increase the speed to deliver applications and services faster. It allows organizations to serve their customers efficiently and become more competitive in market. In simple terms, DevOps can be defined as an alignment between development and IT operations with better communication and collaboration. DevOps helps in achieving seamless delivery, and organizations like Google, Etsy, Amazon have adopted DevOps to achieve levels of performance that are unthinkable even a few years ago. They are doing tens, hundreds, and even thousands of deployment per day while delivering world-class reliability, stability, and security. So I think that is some of the key things that you should basically understand as a DevOps platform. If you are actually delivering multiple enhancements, multiple features on for your various platforms and application landscape, this basically automation provides you with efficiencies and scale to basically deploy those elements, leveraging this CI/CD pipeline. So if you see, Azure DevOps actually consists of various elements. So be it the the boards, the dashboards. Then we have version control. We have builds, which is basically the pipelines to actually sort of provide the continuous integration builds and automated deployment. Then we have the PowerShell, which is the orchestrator, which is the glue which ties all these CI/CD pipelines together. Then we have the Azure artifacts, which is the binaries that are deployed onto production. And then comes a verification, which is basically a code verification or code checking platform that analyzes your code, that your entire development, be it GitHub, be it the local clear case development that you will have, to see if there are any issues in terms of your implementation, be it functional issues or semantic issues, or let's say structural issues. I think these are the sort of elements or solutions that will help you analyze them and probably ensure that they basically provide the right level of quality of code that you need for your solutions. And then comes the release part, which is basically the biceps or the Azure resource management to build the various sort of elements of infrastructure as a core that allows you to build, change, and basically deploy those various elements of your patches and features onto the application landscape. So this is basically about the DevOps. I'll now move to a quick view on what the DevOps pipeline looks like. This is basically, again, the Azure native application that we have. So I think if you see here, I think it starts with version control, which is the GitHub or the Azure repos that we have. Then we go to build and assembly, which actually is basically compiling and interpreting and generating the executable for the for your implementation, which is orchestrated by PowerShell, which is basically our orchestrator. Then we actually go ahead and create binaries out of which is the block D of this slide. Right, so this is basically the overall sort of process around the CI/CD automation. Then we have the code verification, which basically does the code reviews for your implementation. Then we actually do the verification of the functional part of your implementation, which is the block F of our solution of our diagram. So this is basically, while it depicts some of the solutions in here, right? While there are Azure native solutions like Azure Pipeline or Azure Artifacts or Azure Repo, this is basically a kind of a pipeline where you can actually have other tools as well. You can actually plug your open source tools, or you can plug your AWS tools in here. But this is a view on what exactly the pipeline consists of and what automation is required to build these pipelines. So again, as I said, it's basically a Microsoft Azure view around it, but we can have kind of it's typically plug and place. We can have other tools as well. So over here, I've mentioned about Selenium, which is basically a kind of a automated testing tool that we can use for your functional verification. Then it comes to block G, which verifies the non-functional requirements, which is reliability testing, your load testing, stress testing. So this basically depicted a Gatling tool over here. But again, we can have some open source tool or AWS tool actually also building this kind of functionality into your CI/CD pipeline. And finally, there's basically the release deploy, which over here is shown as the ARM, which is basically the tool that deploys to your production, right? So it can be Jenkins as well, which is another open source, very key open source tool that we have today for your release and deployment management as well. So I think this gives a view on your Azure DevOps. So I'll move to the next element of the integration platform, which is the integration.
Just giving you a time check. We've got 5 minutes left.
All right. So I'll try to cover these elements quickly. So this is basically a view on the integration architecture, and this provides you with an integration architecture where the block in the black box provides the is where you have the integration platform. It will typically leverage various elements of the integration platform that we have mentioned about earlier, which is basically be it the service bus or message broker or message queues, etc. At the top, we have the API gateways, which basically is a key component where the internal and external solutions can actually invoke the API. So this is basically the key solution or the key integration architecture that we have. I'll quickly move on to the service mesh, and I'll quickly move on to the event-driven architectures that we have, which actually provides you with elements of the eventing backbone that we have today in the um, uh, in the in the not, complex landscapes that we have today. So this typically actually provides you with elements of the event mesh and the service mesh. So event mesh is basically provides you with the real-time behavior that you would need as part of your application landscape. And service mesh is something that you would need for a request response kind of a sort of feature or capability that you would need to build on in your for your enterprise landscape. So this is basically something that I quickly wanted to touch upon. Both are equally important and critical when it comes to the integration platform, and both are provided by the integration platform. If you need a real-time behavior, I think it's the event mesh that will be required to be deployed. And if you need a kind of a service request response kind of a capability as a service mesh that needs to be typically deployed in your for your landscape. So I think this basically now basically is a depiction of the hybrid integration platform, which is basically a Gartner capability. Again, something that we have already discussed on in the earlier slides of our integration reference architecture, which provides you with the key building blocks in terms of what is required to be considered while you're actually building a kind of an integration platform. But what's important to note is that hybrid integration platform is nothing but a combination of various platform tools from different vendors to basically build a target integration functionality. So this is something that can be leveraged, that can be built using the hybrid integration platform that we have. So this is basically that depiction. Something that is key when you are actually sort of building these and deploying these platforms. On a closing thoughts and on a closing notes, we have covered the integration framework that can help organization position integration tools and approaches within the organization. Thinking in HIP terms is about building the right foundation for integration in an organization. It is also about recognizing the foundation that are already there and not assuming a mistake was made when we discover integration requirements with our current tooling or approach. We should seek to rationalize our integration investment where possible. More importantly, we should be seeking to understand the value of any given integration outcome, making sure it stacks up when selecting an approach. Using an agnostic integration framework, as we saw earlier, as part of the integration strategy, can help an organization to remain objective about its technology choices. Integration technologies and markets that are constantly evolving. Vendors typically aren't looking for customers to spend less with them year on year. They are looking to grow the annual recurring revenue or TCV with their customers. Being agnostic of technology enables the buyer to seek out better value or better aligned value in the choices they make. Your no claims discount with your car insurance is generally more valuable to you when you change insurer than it is to your incumbent supplier. Integration is harder to move than car insurance, but not as hard as it was initially implemented. Organizations may well find integration processes built historically in one technology stack can yield better ROI in another technology in the portfolio of tool. If it isn't broken, if it isn't broken, don't fix it. It doesn't mean you can't move it. While digital impacting each function of the business, there is a need for a layer that is inherently event driven, along with being environment agnostic and dynamic. The user experience has altered the businesses in becoming more outward and understand custom customer needs and responses, resulting an ecosystem that is more real time and engagement driven. the traditional approach of being data centric has now evolved to being event centric. The need is for an agile and scalable solution that can deliver event driven architectures, providing secured data distribution along with identification of meaningful events that are easily stored and provide instantaneous access as and when required. And finally, in today's digital era, businesses need sophisticated event analysis instead of traditional message-oriented middleware. The need for having event distributed via orchestrating and connecting microservices and pushing events from on-premise cloud, thereby enabling the digital experience across lines of businesses and IoT, can be delivered via an event mesh, which also provides agility, real-time responses in a secure manner. And event-driven architectures will continue to be the backbone for tomorrow's infrastructure. That completes the presentation. Uh, uh, Thank you all, and I'll hand over to Dale.
Samir, that was amazing. Thank you very much for your time today. There's so much information in there, and I've been through this process before with several organisations, and I can see so many things that I think I need to go back and rewatch this presentation and sharpen up my my approach to things and increase my knowledge. It's fantastic you've been able to share that with us today, and we really appreciate your time. Thank you.
Thank you, Daryl.